They were never erased from history. They were never truly gone. What disappeared from the landscape did not disappear from the human story. The Neanderthals did not fade into extinction. They merged into us. For centuries, they were portrayed as a failed branch of humanity. Heavy-boned, slow, primitive, a species overwhelmed by the rise of Homo sapiens. This narrative dominated textbooks, documentaries, and imagination alike. But modern science has dismantled that version of the past. Genetic evidence now tells a far more unsettling and fascinating story. Neanderthals survive inside modern humans. Their legacy pulses beneath our skin, embedded in our DNA, shaping who we are in ways we are only beginning to understand. But before we jump back in, drop a comment letting us know what time you're tuning in and where you're watching from. We love seeing how far our episodes are reaching. And don't forget to hit that subscribe button. It really helps us keep bringing exciting topics here on the Primal Roots channel. The story begins roughly 400,000 years ago. In Europe and large parts of Western Asia, a lineage of humans evolved under brutal conditions. Long winters, weak sunlight, scarce resources. These people became what we now call Neanderthals. Their bodies were compact and powerful, built to conserve heat. Their bones were dense, their muscles strong. Their faces broad, with pronounced brows and large nasal cavities designed to warm cold air before it reached the lungs. Their brains were not smaller than ours. In many cases, they were larger. They were not simple survivors. They were skilled hunters who brought down massive animals at close range. They controlled fire with precision. They crafted tools adapted to their environments. They buried their dead, sometimes with objects placed beside them, suggesting care, memory, and meaning. Injured individuals were supported by their groups, evidence of empathy and social bonds. These were not mindless brutes. They were intelligent, resilient humans shaped by extreme worlds. While Neanderthals were adapting to Ice Age Europe, another human strategy was unfolding far to the south. In Africa, Homo sapiens evolved along a different path. Lighter bodies, greater endurance, increased mobility, more complex social networks, advanced communication. These differences were not signs of superiority or inferiority. They were adaptations to different challenges. Around 60,000 years ago, Homo sapiens began migrating out of Africa. As they moved north and east, they entered territories that had been home to Neanderthals for hundreds of thousands of years. What followed was not a single encounter, but a long period of overlap. For thousands of years, these two human forms shared landscapes, climates, prey, and dangers. And they did more than coexist. They met, they bonded, they reproduced. For a long time, this idea was dismissed. The assumption was that different human species could not or did not interbreed. That belief collapsed in 2010 when geneticists sequenced the Neanderthal genome and compared it to modern humans. The results were undeniable. People of non-African ancestry carry between 1% and 4% Neanderthal DNA. This was not a rare accident. It was widespread, repeated, and consequential. Neanderthals did not vanish. They were absorbed. That absorption left marks, deep ones. Neanderthal genes influence how our immune systems respond to pathogens. Some help defend against ancient viruses. Others increase the risk of autoimmune diseases today. Certain genetic variants affect skin thickness, pigmentation, and sensitivity to sunlight. Others influence bone density, muscle structure, and fat storage. There are even links to sleep patterns, circadian rhythms, mood regulation, and susceptibility to depression. In other words, Neanderthals helped shape the modern human body and mind. The image of Neanderthals as inferior collapses under this evidence. You do not inherit traits from a species that was biologically irrelevant. You inherit from survivors, from humans who endured environments that would kill most populations. Their adaptations were valuable. Homo sapiens did not replace them simply by force. In many cases, sapiens benefited from what Neanderthals already knew, already were. This realization changes everything. Human evolution is no longer a straight line of progress. It is a braided river, splitting, reconnecting, exchanging genetic material, knowledge, and survival strategies. The idea of a pure human lineage dissolves under scrutiny. Humanity is hybrid by nature. Every person alive today outside Africa carries fragments of Neanderthal history, tiny genetic echoes of a different humanity that once walked frozen valleys, hunted beneath pale skies, and endured conditions that shaped their bodies at the molecular level. These fragments are not passive relics. They influence health, behavior, and biological responses in the present. The DNA inside us functions like a time capsule. It preserves adaptations forged tens of thousands of years ago. But evolution has no sense of morality or foresight. Traits that once provided survival advantages can become liabilities in modern environments. A gene that conserved energy during famine may contribute to obesity today. A heightened immune response that once protected against infection can now trigger chronic inflammation. Yet without these inherited traits, Homo sapiens might not have spread so successfully across the planet. This is the paradox of Neanderthal legacy. They disappeared as a distinct population, but their biology helped build the modern world. Their extinction was not a clean ending, it was a transformation, and it forces a deeper question. If Neanderthals had culture, empathy, intelligence, and social bonds, what truly defines being human? Where does one species end and another begin? If our bodies are mosaics of different human forms, then humanity itself is not singular. It is collective, shared, interwoven. The past is not buried in caves and fossils alone. It breathes inside us. Neanderthals were not strangers. They were relatives, and the story of who we are cannot be told without them. DNA is not just a biological code. It is a record of survival, a molecular archive of choices made under pressure shaped by cold, hunger, disease, and uncertainty. Within the human genome, fragments of Neanderthal DNA persist not as relics, but as functional elements that continue to influence modern life. When Neanderthals and Homo sapiens interbred, the exchange was not random. Natural selection immediately began filtering which genes would persist. Some Neanderthal traits vanished within a few generations. Others proved advantageous and were retained. Over time, these genetic fragments spread through populations as Homo sapiens expanded across Eurasia. One of the most significant contributions lies in immunity. Neanderthals had endured Eurasian pathogens for hundreds of thousands of years. Their immune systems had adapted to local viruses, bacteria, and parasites long before sapiens arrived. When sapiens entered these environments, they were immunologically vulnerable. Interbreeding provided a shortcut to adaptation. Several Neanderthal-derived genes enhance innate immune responses, particularly those involved in recognizing and reacting to pathogens. These genes helped early modern humans survive unfamiliar diseases. Without them, mortality rates during migration would likely have been far higher. This genetic inheritance may have played a critical role in the rapid expansion of sapiens across colder regions. However, immunity is a double-edged sword. A system designed to react aggressively can become a liability in modern environments. Today, some of these same genes are associated with autoimmune disorders such as lupus, Crohn's disease, and type 2 diabetes. What once protected against infection now contributes to chronic inflammation. Evolution does not optimize for comfort or longevity. It selects for survival under immediate conditions. Skin and hair also bear the imprint of Neanderthal ancestry. Variants linked to keratin production influence skin thickness, hair texture, and nail growth. These adaptations likely offered protection against cold, wind, and low ultraviolet radiation. Lighter skin pigmentation facilitated vitamin D synthesis in regions with limited sunlight. These traits spread rapidly because they solved real environmental challenges. Sleep patterns offer another window into this ancient inheritance. Some Neanderthal genes affect circadian rhythm regulation. Research suggests a link between Neanderthal DNA and a tendency toward evening alertness, or disrupted sleep cycles. In Ice Age environments with long periods of darkness or shifting daylight, flexible sleep patterns may have been advantageous. In the modern world, they can manifest as insomnia or irregular sleep behavior. Metabolism tells a similar story. Certain Neanderthal variants influence fat storage and energy use. In environments where food was unpredictable, efficient energy retention was critical. These genes helped individuals survive prolonged scarcity. In contemporary societies with constant access to calories, the same adaptations can increase the risk of obesity and metabolic disorders. The skeletal system also reflects this genetic exchange. Neanderthals possessed dense bones and strong muscle attachments, traits linked to physical robustness. Some of these characteristics persist subtly in modern populations, influencing bone density and muscle composition. These traits may have enhanced physical endurance and resistance to injury in harsh terrains. Beyond physiology, emerging research suggests that Neanderthal DNA may influence aspects of behavior and neurological function. Certain genetic regions associated with mood regulation, stress response, and risk tolerance show Neanderthal origins. While these influences are complex and probabilistic rather than deterministic, they raise profound questions about the deep evolutionary roots of human behavior. Aggression, caution, resilience, anxiety, adaptability. None of these traits exist in isolation. They are shaped by thousands of interacting genes and environmental pressures. Neanderthals lived in small groups, exposed to constant danger from predators, climate extremes, and resource scarcity. Behavioral traits that favored vigilance and rapid response may have been essential. When inherited by sapiens, these tendencies became part of a broader behavioral spectrum. Importantly, Neanderthal genetic influence is not uniform. Different populations carry different fragments. East Asians, for example, often have slightly higher percentages of Neanderthal DNA than Europeans, suggesting multiple interbreeding events in different regions. Africans, while carrying little direct Neanderthal DNA, possess genetic traces of other archaic human populations, reinforcing the idea that interbreeding was a common feature of human evolution. This mosaic pattern reveals that humanity did not emerge from isolation. It emerged from contact, from overlap, from exchange. The boundaries between human groups were porous, not absolute. Species definitions blur when viewed through the lens of genetics. The disappearance of Neanderthals as a distinct population likely resulted from multiple factors. Climate instability reduced habitable zones. Small population sizes increased vulnerability. Competition for resources intensified. But genetic absorption ensured that their biological legacy did not end. Instead of extinction, their story became integration. The study of ancient DNA has transformed anthropology into a molecular science. Fossils alone could not reveal these hidden connections. Bone fragments offered shape and size, but not lineage. DNA sequencing unlocked a new dimension, allowing scientists to trace ancestry with unprecedented precision. Each newly sequenced genome refines the picture. Patterns emerge showing how genes moved across populations, how traits spread, and how adaptation unfolded over millennia. Human history is revealed not as a linear ascent, but as a network of interactions. This understanding has practical implications today. By identifying Neanderthal-derived genetic variants, researchers can better understand disease risk, drug responses, and population-specific health vulnerabilities. Medicine increasingly recognizes that evolutionary history shapes modern biology. Yet the implications extend beyond science. They challenge long-standing assumptions about human uniqueness and dominance. Neanderthals were not evolutionary failures. They were humans adapted to different conditions. Their disappearance does not diminish their importance. If anything, it amplifies it. To carry Neanderthal DNA is not to carry something alien. It is to carry evidence of connection, of shared struggle, of cooperation under pressure. The human genome is not a monument to purity. It is a testament to survival through diversity. As research progresses, the line between us and them continues to dissolve. The traits once used to separate species are now understood as variations within a broader human continuum. Intelligence, creativity, empathy, and adaptability did not belong exclusively to one group. The Neanderthal legacy reminds us that evolution favors flexibility over isolation, that survival often depends on exchange rather than exclusion, and that the story of humanity is richer, deeper, and more complex than any single lineage could explain. What remains in our DNA is not just biology. It is history encoded at the molecular level, a reminder that modern humans are not the result of replacement, but of convergence, that beneath cultural differences and modern identities lies a shared, hybrid origin. The past does not lie behind us. It exists within us, shaping how our bodies function, how our minds respond, and how we adapt to the world. The Neanderthals are not gone. Their genetic echo continues, silent, persistent, and profoundly human. Humanity did not emerge fully formed. It assembled itself over time through encounters, exchanges, and adaptation. The modern human is not the product of isolation, but of contact. Neanderthals are proof that evolution does not simply erase what came before. It integrates what works. For much of the 20th century, human evolution was described as a competitive ladder. One species replaced another through superiority alone. This framework now appears incomplete. Genetic evidence reveals a more complex dynamic in which coexistence, interbreeding, and cultural overlap played central roles. The disappearance of Neanderthals as a distinct population was not a clean extinction. It was a biological and historical convergence. This convergence reshaped Homo sapiens. The absorption of Neanderthal genes altered physiology, immune response, metabolism, and potentially aspects of cognition. These changes were not uniform or predictable. They varied across regions and populations, reflecting local environments and selective pressures. The result was not a single outcome, but a spectrum of human diversity. Hybridization is often misunderstood as weakness. In reality, it is one of evolution's most powerful tools. Genetic mixing increases variability, and variability expands the range of possible adaptations. In unstable environments, this flexibility becomes decisive. During periods of climate fluctuation, ecological stress, and resource scarcity, populations with greater genetic diversity are more likely to survive. The late Pleistocene was defined by instability. Rapid temperature shifts, advancing and retreating ice sheets, and changing ecosystems placed constant pressure on human populations. Neanderthals had already adapted to many of these conditions. When sapiens entered these landscapes, hybridization offered immediate advantages. It transferred solutions refined over hundreds of thousands of years into a new population, expanding across unfamiliar territory. This process challenges the idea of evolutionary dominance. Homo sapiens did not prevail because they were biologically flawless. They prevailed because they were adaptable. They absorbed traits, strategies, and genes from other human groups rather than eliminating them entirely. Survival was not driven by purity, but by integration. The concept of a pure human lineage dissolves under genetic scrutiny. Every modern population carries a complex ancestry shaped by migration, interbreeding, and local adaptation. Even within Africa, where Neanderthal DNA is rare, evidence points to gene flow between multiple archaic human groups. Human evolution is not a straight path, but a braided network. This understanding reframes identity at a biological level. Species boundaries, once thought rigid, appear permeable. Behavioral, anatomical, and genetic differences did not prevent interaction or reproduction. Humanity was never a single, isolated entity. It was a collection of closely related populations navigating the same planet under different conditions. Neanderthals also force a reassessment of intelligence and culture. Archaeological evidence suggests symbolic behavior, technological innovation, and social complexity. Pigment use, personal ornaments, carefully crafted tools, and structured living spaces indicate cognitive capacities comparable to early Homo sapiens. Cultural expression did not emerge suddenly with sapiens. It evolved gradually across multiple human forms. This continuity undermines narratives of abrupt superiority. The differences between Neanderthals and sapiens were matters of emphasis, not absolutes. One group favored physical robustness and localized adaptation. The other emphasized mobility, extended social networks, and cumulative culture. When these strategies intersected, hybrid populations inherited elements of both. The long-term consequences extend into the present. Modern health, behavior, and biology cannot be fully understood without evolutionary context. Genetic variants inherited from Neanderthals continue to influence disease susceptibility, stress response, and physical traits. These influences are subtle, interacting with thousands of other genetic and environmental factors. But they are real. Medicine increasingly recognizes this evolutionary legacy. Personalized health strategies now consider ancestral genetics, population history, and adaptation patterns. Understanding why certain populations respond differently to diseases or treatments often leads back to ancient migrations and genetic exchanges. Beyond medicine, the Neanderthal legacy carries philosophical weight. It challenges exclusivity and definitions of humanity. If Neanderthals experienced empathy, cared for their injured, created symbolic objects, and formed social bonds, then humanity is not confined to a single lineage. It is a shared condition. This realization alters how history is interpreted. The past becomes less about winners and losers and more about continuity. Neanderthals did not fail. Their environment changed. Their population numbers declined. Their genetic legacy persisted. Evolution did not discard them. It redistributed their contributions. The future of human evolution will likely follow the same pattern. Cultural and technological forces now shape selection more than climate alone, but the principle remains. Adaptation arises from diversity, exchange, and flexibility. Isolation limits possibility. Integration expands it. As humanity faces global challenges, climate change, emerging diseases, environmental instability, the lessons embedded in deep time become relevant again. The resilience of our species has always depended on cooperation across differences. Biology reflects this truth as clearly as history does. The Neanderthal story also reshapes how extinction is understood. Extinction is not always erasure, sometimes it is transformation. When populations merge, their identities change, but their influence endures. The disappearance of a name does not mean the disappearance of its substance. Modern humans are not separate from this past. Every genome carries fragments of ancient lives, ancient struggles, and ancient solutions. These fragments influence how bodies respond to stress, how immune systems react, and how populations adapt to new environments. The human species is not a finished product. It is an ongoing process. The same forces that shaped Neanderthals and sapiens continue to operate, albeit under new conditions. Genetic exchange, cultural transmission, and environmental pressure remain central to survival. Understanding this lineage fosters humility. Humanity is not the result of inevitable progress, but of contingency. Small populations survived by chance, by cooperation, and by adaptation. The survival of sapiens was not guaranteed. It was made possible through connection. Neanderthals remind us that intelligence, creativity, and resilience are not exclusive traits. They emerge wherever humans confront uncertainty and persist. The distinction between modern and archaic becomes less meaningful when viewed through the lens of shared humanity. The story of Neanderthals is not a footnote. It is a foundation. It reveals that the strength of our species lies not in separation, but in synthesis. Not in purity, but in complexity. The past is not distant. It is embedded. It shapes the present and informs the future. Humanity carries its history forward not as memory alone, but as biology. The Neanderthals never truly vanished. They became part of what followed. And in doing so, they helped define what it means to be human. Don't forget to subscribe, It really supports the channel and helps us bring you more great stories.